All right, hello. Thank you for coming to my channel. Today I wanted to chat a little bit about linked lists. This is something that a lot of young developers, myself included, struggle with right when they started off. So I wanted to do a little video talking about this and honestly why we need it and how we implement it in using JavaScript. So let's say you had, and we're not going to code anything, we're going to give an example of how linked lists look and how they work. So let's say you were a participant of the Amazing Race, and each time you visit a city, you're kind of given a direction or an address to get there. So before you even start, you're given a sheet of paper that tells you, we can call this a start paper if you will, and it tells you what the starting location you need to go to. So maybe it's Minneapolis. Okay? Oh, less. Can't spell, so that's going to be a problem today, right? So you get a sheet of paper and it just tells you the start point, and that's all this paper knows. It doesn't know what's there, that location. It doesn't have anything to do with it. It just knows that's where your starting location is. So you get this paper and you're like, okay, cool. I'm going to go to Minneapolis. So the first city you visit to, and we're not going to do this like a map. We're just going to draw cities and just point them to each other. So pun intended on that one too. So given a city, Minneapolis, here's our point, and maybe when we visit that city, maybe we get some kind of monetary value. Maybe at that city we got like $100. So at that city we got $100. We'll denote that as like a value, right? But also, when we go to that city knows the next place we need to go to, right? So maybe it also knows like, okay, here's your value. The next city you're going to visit is Seattle. Okay, so that city doesn't know what the value is at that city. It doesn't know anything else. So maybe when you go to Seattle, kind of the same thing happens, right? It has some kind of value. Maybe the value here is just $1, horrible city to visit if you're playing the Amazing Race. And maybe it knows the next city you're going to visit. Maybe this city is Portland. We're running out of cities that I know. This is kind of bad. All right, so that city knows its value and it has a next pointer to Portland. So maybe you go to Portland and Portland says, hey, I have a value and my city's worth a lot. So here we have $1 million, and the next city there's none. So maybe we'll just say none. So it knows it's the last city. So right now, if we recap this, right, we have a start point that only knows the start, and every time we visit a city, it knows its value and the next city that you're going to visit. If you're visiting each city, it doesn't know what city's after this next city that it points to. If it points to one, the only thing it knows is what's coming after it. And that's pretty much the basics around what a linked list is. Linked list very much will look like this if we were to diagram it out. It's a collection of objects that have one pointer to another object, hence singly linked, right? But the question is, like, why do we need to use something like that? Like, before we actually talk about why, let's actually just implement this and show how this will be written in code. And we're gonna pretty much, the diagram that we just drew on the board, we're pretty much going to mirror that. So what we're going to do, and actually before we actually build like how I would build this in JavaScript, let's actually just draw a simple version of this and then let's show like actual implementations of it. So how we could do something like this in JavaScript, we can say var city 1. And we can set this, let's just set it equal to an object. And let's say our city 1, if we're looking back at our code, if we were thinking about our diagram before, what did our diagram know? Well, our diagram, each object, each city in that diagram knew a value that it had and the next city, right? So let's say this value right now the value for this city is 1. And let's set initially, let's set its next city or next, whatever we want to call it, equal to null. And if you're new to this, null just means nothing, empty of values, right? So there we go, there we have it, right? We have our first city. And we can put more values in here, and that's probably a good thing to know, is that our linked list doesn't need to follow this exactly. We can put more things in these objects if we want. Our next city, let's save our, and let's actually go ahead and do that. Let's put a city name, because all we have is city here. Let's do name in our object equals Milwaukee. Cool. And we'll make that a string. Perfect. So hopefully you guys can see that on the board. Hopefully I'm not writing too small. Okay, so let's do city 2. City 2. So what we'll do here is do val at this city equals maybe 2, and let's do another value. Let's do 100, and let's do next. Its next will also equal to null, because we're going to start them off without knowing each other, and we're going to say name of this city equals, I don't know, Chicago. Okay, perfect. So right now, all we have is 2 objects that have no relation to one another, right? So what we need to do now is connect them. Right now, if we look, both of their cities point at null, which is same as our diagram to nothing, like there's no city next. And let's say we want to start this where city 1, the next city that you would visit is city 2, right? So how we could do that is we're going to use this next property and point it here. So we would say city 1 dot next equals city 2. Now that's our code, and that connects city 1 to city 2. So if we looked inside this in actual code, it would show city 1's dot next is this whole city that it points to. Now there's a couple things happening here. Like how does this work? How does the next property actually point to this whole object? And honestly, why do we need this? For those of you who have probably been coding for a while, you probably have been using something similar to like an array, or actually have, not similar to, an array, right? You've probably been using that a lot. And you might say, like, well, array, like, why would I ever want to do that? Why would I ever want to use a linked list? Well, let's talk about this. And we're going to use general, and we're going to come back to that. We'll actually code it out in a second. But let's diagram a couple things here, and let's check this out. So consider this our computer's memory. Each box here is a slot in memory. We're going to use arbitrary numbers, single-digit numbers. Our computer wouldn't have single-digit memory boxes like this, but we're going to use this for simplicity. And let's say each box holds something for us. So this is a spot in memory, okay? So when we have spots like this in memory, when we store an array, let's say we create an array, let's say we have var x equals 1, 2, 3. Okay? So now we have variable x equals 1, 2, 3. Let's show how this variable x will store this array in our computer. Well, one thing about arrays, they have to be stored continuously in memory, meaning they just need to be next to each other in memory. And just for all of you guys out there who probably know a little bit more about this, we're talking general purpose CS stuff, general for all languages. Some languages will handle this a little bit differently, but we're just kind of talking about general purpose here. So let's store this how our computer would store it. So what it will do is kind of block off, find 3 spots in memory that it can store, and store those values next to each other in memory. And our computer would know like these 3 spots belong to this array contiguously, right? They need to be next to each other. So we know that, right? This is how it's stored. And whenever we console log to grab it, it would go to this spot and grab any value that it needs. Okay, so let's say we need to add a value to this. Now, for those of you, again, who know this, you might just do x dot push, and maybe you want to push the value 4, right? Well, remember what I said, that our values here need to be continuously stored in memory. So our computer will say, okay, here's the next value. I can put value 4 here, and make this just a little bit bigger. I'm going to push it there, and that works fine, right? Well, for that example, that worked perfectly. But herein lies the problem. Let's say, the next lines, as long as we go in order, like 1, 2, 3, 4, 5, that this is right after the number 4 box, okay? Let's use a pound sign to say that this box is taken up by something else in memory, okay? So this box is used by something else. We don't need to know exactly what it is, but it's used by something else in our computer. So let's say now we wanted to push 5 into this array. Well, we can't just push it here to this box. We couldn't just do that. We couldn't just skip this box and push it here. What we're going to need to do is pretty much move this entire box to a spot that it can fit this many items plus one more, okay? So let's say we move it here. So we have 1, 2, 3, 4. I'm gonna make this just a little bit bigger so we can see it on the computer screens. And now we can push this value here, right? But that seemed very easy, like at least writing it, but how many items do we have to move? Well, we have to move 4 items and then push the new item there. Seems very easy, at least with 4 items, but what if our array had 1,000,000 items? How many items would we be moving then? Well, we'd be moving 1,000,000 items, and that is not very efficient. So there's gotta be a better way. I'm kind of using Python verbiage on this, but there's gotta be a better way, right? Also, in addition to that, let's do a couple other things. So we know arrays, if we need to add items to it, and they're not continuously stored in memory, we need to move n items, right? Another thing is, let's say we wanted to, let's go back to our original array. So let's go back to our original array here. And I didn't erase this, but after it copied that item, it would have probably erased it. Not probably, it would have erased this because it would have got garbage collected. But just so you guys know that it wouldn't exist twice in memory. So let's redraw this. So let's say we wanted to add an item in the front of this array while keeping all of our other items here in check. Well, some of you guys have probably done this in code, right? Probably just written out like a for loop, moved everything down and made room for this to put something in this front array of 0, right? Because we couldn't just say here, like just push a value, because now we've overwritten the 1 and we've lost it, right? We would have to move every value from the end 1 spot over to make room for this, and then push it here. And you can consider this just like a regular shelf that you have. If you were going to make room on your shelf for an item and you're using this array, you have to take items starting at the end, at least with this, because we don't want to overwrite anything. And you can kind of see one of the problems here. This has to be free, otherwise we're going to have to find a new spot in memory to move this. But let's assume that this is free, and let's copy this over. So let's make a spot for another value that we're going to put here. So we're going to make that, we're going to push that here. We're going to push this over here. We're going to push this over here. And we're going to push this here. And I didn't do that as of how we actually do it in the computer. I didn't do it in order of how we would do it. But if you worked on that algorithm before, you'll know how to work on that and write it. Okay, but now we've efficiently made a spot in our array to push that value 99. So we would push it here. But it seemed very easy again, at least what we're doing, but we had to touch n items to make that happen. If this array was 1,000,000 long, we'd have to shift over 1,000,000 items to make room in our front of array for 99. Not efficient at all. And there is a better way to do this. The same would happen for delete. And let's talk about that too before we move on. If we wanted to delete this 99 without making a new array, keeping this in place, we could overwrite each one, kind of going through this. Oops, I didn't erase the end of that array there, so sorry about that. We can erase it and then cut off the last value, but still, we need to touch n items, right? Not great. So this is where linked list comes in. Pretty much all the things that I showed you that arrays were bad at, linked lists will do a little bit more efficiently. And what are we doing with the linked list? Well, honestly, all we're doing, let's say we're using the same diagram. Say this is our computer, and let's say we kind of have that diagram from what we had earlier. And we're going to do this very simply. let's say we have var x, and we're going to say x equals, x is going to be very similar to our city. So it has a value of 1, and this next is null. Hopefully you guys can see that. I'm going to move this just so you guys can see that. Perfect. And then var y equals val of 2, next, null. Okay. Okay. So how would this look? Well, let's say again that we have a couple of things taking up memory in our computer. Okay. Let's say all this was taken up by other things in our computer, so we can't use those spots. Well, when we wrote this var x, our computer took this object and put it in the first memory block that it can find. Again, we're just simplifying this. There's a little bit more that happens here, but we're going to simplify this so you can kind of see the benefits of linked lists. Well, our computer sees that box 1 is open, right? So let's store this in our box. So let's say val here is 1, and its next is null. And hopefully you guys can all see that. But all we have here is the object in that box, value, next, null. That's what we've stored in that box. Okay? Cool. So let's say now we want to store our next value here. And let's say we can't store it in 2 because 2 is already taken, 3 is already taken, 4 is already taken, 5 is already taken, and 6 is already taken. So the next box we can store this in is here, right? So we would store this here. And we would say val 2, next, null. Okay? Perfect. All right, so that's box 7. So now, just so you guys know, our variables here don't really equal the object anymore. They would equal the memory location in which they're stored. Okay, so x would equal what? Just take a look at this. What would x equal? If you said 1, you're correct. What would y equal? If you said 7, and I know I wrote that small, you are correct. So that's what those will pretty much equal now. And let's do that a little bit neater. Okay, so that's what they would equal. So if we counterlog x, what our computer would do, especially if we're using JavaScript, it would go to that box and show you everything that's in that box. So x equals 1, go to box number 1, show you what's in that box. Very straightforward right there, right? When we did, okay, so now let's connect these two because these have no connection right now, right? They have no connection to each other. They're just two boxes of memory that aren't really linked in any way. So let's link them. Let's say we want x, that's next point here. Well, how we write that in code is x. So we'll go to box 1, okay? Dot means go inside of that box. We're going to set the next property. So this property that's inside that box equal to y. Now here's where like the magic happens, right? When we set this, what we're going to do is set this dot next not equal to this actual object. I know I said that earlier, right? That we're actually setting it equal to object, but we're not. We're actually setting it equal to the memory location of that object. And let's say memory location of that object is just 7, right? So when we do this, when we wrote this in code, x dot next equals y, that equals 7. Now again, just so you are aware, you will not see this memory location in JavaScript. In some other languages, depending on how you write it, like in Python and Java, depending on how you write it, you will see a memory location. It will be some long number, maybe some hexadecimal number or something. But in JavaScript, you won't see it. It will show you the whole object that's in that box. Simplicity, right? And JavaScript kind of is like our buddy when it comes to that. And let's show that. If we console log x dot next, well, how our computer will walk through is just how we talked it out. X will go to that memory location, which we see is box number 1, right? So we go to box number 1, right? Dot means go inside that box. Next, we go to this box, number 7, and then we show everything that's in that box. So here's the benefit of using linked lists instead of arrays, right? We don't have to have these objects stored next to each other in memory. We do not have to do that. We can have these items stored anywhere in memory as long as they point to each other, right? So this now points to this box. We can have more, they can be any order, as long as the box is empty, and that's kind of how this would work out. So there you have it. This does a lot of things better than arrays. We don't have to have this stored continuously in memory. Insert is a lot easier depending on where it is in the array if you're keeping track of it. But insert will be a little easier. We'll talk about that in a later video. But you guys can see kind of like the benefit here, especially when it comes to contiguous or not. So you might be saying to yourself, why would I ever use an array if this is more efficient? Well, it's not in a lot of cases. And in our future videos, we'll talk about that. I'll make a couple videos talking about linked lists. But this should get you started on the basics of linked lists. Thanks, guys.